Thank you for coming to the talk here. The last talk before lunch, so you guys are the brave souls. I promise to be done by 12:45. This talk is about optimizing multilingual search in Solr. And there have actually been a few talks about multilingual search, so I think this is definitely one of the themes, one of the major themes of this conference. I've seen 3, maybe 4 talks where this is the primary topic, and then I'm sure there are a bunch of others that at least touch on it in some way. So that I think tells me that it's an important topic and that a bunch of you are probably dealing in multilingual search right now, or maybe you're thinking about it or thinking about expanding that capability. Quick overview of the talk. So, first thing I'll just define what we mean by multilingual search. Seems pretty straightforward, but there are a couple little nuances that we'll define in the problem. I'll spend a good amount of time talking about text analytics and natural language processing. So I think it's important, even in the monolingual search case, for you to have an understanding of this. So there are probably a lot of developers in the crowd that maybe have no linguistics background at all, and maybe you have people in your organization, maybe on the business side, who will come to you and just say, search in Chinese is it's bad, fix it. And hopefully this second bullet here will arm you with some of the reasons why that might happen and some of the things you can do to fix that. And then finally, this will focus on approaches to multilingual search in Solr, and some comparisons in terms of functionality and performance and things like that. So something that, a point that always comes up in tech conferences, and especially in LucineRev, is that there's never just one prescribed way to do something, or hardly ever. That's certainly the case with multilingual search in Solr. My answer to you is unfortunately going to be it depends, but maybe that's a good thing because we all get to keep jobs. All right, so let's just start with a quick multilingual search example. So this is our favorite website, Google. So I went in and just typed Serie A into the search box. So Serie A is a Italian soccer league. So if I just type that into Google, generally my results will be in English because Google has some information about me and knows which endpoint I'm hitting and all of that. But a few pages down, page 3 of my results, if you look at the second result here, Google has put an Italian news website on there in my results. So this is an example of multilingual search in a couple of different ways. First is my query isn't necessarily English, not necessarily Italian either. It just is what it's a named entity, and named entities are particularly problematic in multilingual search because whether you have an English website or document, or a Spanish one or a French one, or I'm sure countless others, this league will be referred to in that same exact way. So here's an example where your query could be across languages, and of course the document corpus here spans multiple languages. The web is obviously richly multilingual. So the goal here is to not build Google, but with Solr, build a search engine where your document corpus spans multiple languages, so that'll be a constant here. Maybe your documents themselves will be mixed language, so if your document corpus is, say, emails or something like that, and you have an email that's mostly English, and then the person copies in a little blurb of Spanish, that's an example of a mixed language doc. And then your queries may be within a language, they may span multiple languages, maybe you don't know the language of your query, so that's where, if you're thinking about multilingual search, you have to think about your application and what applies at query time. Okay, so this is this should be a pretty straightforward diagram of the basics of search. This isn't even Solr, but generally on the query side and where NLP fits in, so NLP, natural language processing. So on the query side, you start with some query string, Clinton speaking. This is your search box. That goes through an NLP pipeline. We'll talk about some of the steps of that, but the key here is that you have an NLP pipeline that gives you tokens or terms, right? And those terms end up being the keys in your index. So here, Clinton speaking goes through a pipeline and arrives at the terms Clinton and speak, so there's some tokenization happening to break that up, and then there's some normalization that takes speaking down to speak. So that's all happening in this pipeline. And then, of course, on the indexing side, you have the same exact thing happening, generally the same exact thing, and this is how you get recall and how you get words to match regardless of the form that they're in. So in this case, my document 123 that's down in my inverted index, that got there from a document that's Bill Clinton spoke about, blah, blah, blah. So that text was sent through the same or a very similar NLP pipeline that tokenized and happened to lemmatize spoke to speak, so that when you Google, when you search for Clinton speaking, you'll get a match on this. So here it is, both sides. Okay, so let's talk a little bit more about the NLP pipeline. And like I said, I hope that one of the things that I want you to get out of this is that if NLP and text analytics are new to you, even if you're not doing multilingual searches, hopefully get some bits out of this. So some of the processes that happen within the NLP pipeline, language detection, tokenization, decompounding, word form normalization. And I'll define all these and give examples. Starting with language detection, it's of all of these, it's really not like the others in a few ways. So the first thing is that it's generally optional, whereas the others aren't. So often you want to detect the language of a document at index time. Sometimes you may not. The easy case is when you just know the language of your document for whatever reason. Say your application is just organized that way. You know the language of your documents. You don't even need to deal in language detection. The other difference is that typically this is only used at index time. It's generally not used at query time. And the reasons for that, there are a bunch. One is that language detection is generally better and more accurate the more text it has, and queries tend to be short. Sometimes, like in the Serie A example, you can't even have a human know what language a particular query is in, so you have no shot at a machine getting that right 100% of the time. So named entities are particularly problematic and often appear in query strings. People search for things very often. Third bullet I mentioned is that your end user app may already know it. NLP is great, but why call, you have to admit that it can be wrong sometimes and there's a performance cost. Why do it if you don't have to? And then the final one is really, there's not really a plug-in pattern in Solr to do language detection at query time. So is anyone familiar with the language detection, language detectors in Solr? Have people used it? Okay. So language detection is not specified within your field type. It's specified in an update request processor. So first off, that means that index time, and second, really the job of language detection, at least as the pattern that the Solr community has defined it, is that you have a document with multiple fields, and you want to maybe look at multiple fields in order to determine the language of that document, and then you may also want to you probably also want to write that language into another field. So because you need access to multiple fields, you can't accomplish that in a field type in general. So that's another reason. Okay, but for all the other processes I mentioned, tokenization, those are happening within your field type. So tokenization, simply breaking text into words. If you're an English speaker only, or maybe Latin languages, say, and a bunch of others, say non-CJK, then breaking text into words is probably doesn't seem like a hard problem to you. Like if you were, if you've taken, intro CS, you can take and someone asks you, okay, here's a piece of English, can you tokenize this for me? Here's a big string, return a list of strings that are the tokens. Anyone with the most basic knowledge of any programming language can just break on white space and do a pretty good job in English. Unfortunately, in other languages, that's not the case. So here's some Japanese. Find the words, right? How does a machine do this? So that's just something to keep in mind here. We'll come back to CJK in a little bit. Decompounding is breaking compound words into subcomponents. So again, if you're like me and English is your language, maybe have dabbled in a little bit of other languages, compound words don't seem like a problem. They don't seem like something that comes up often. In Dutch, German, Korean, other languages like that, people freely just toss words together, which makes it hard when it comes to search because, for the same reason that you want to tokenize on white space or break words on white space or whatever, you want to break words into their compound components so that searches of your subcomponents can match documents that contain words in the compound form and vice versa. Okay. Word form normalization. So this is taking any form of a word, say different ways that verbs are manifest, and collapsing them down into a canonical representation, or maybe a small handful of those. And this is critical for recall. So the two approaches to that are stemming lemmatization. You're generally going to do one or the other. And like I said, this is very important. Especially important. So I think if you're an English speaker, you get it. It's very important. You can think of examples where it applies. In other languages, I think Arabic is it's even more critical in Arabic, where the set of forms that certain words can appear in is even larger than in English. So stemming is basically a rules-based approach. Chop off the end is generally what it's doing. And there are various options for stemmers. Some chop more off and chop less, so there's a little bit of a trade-off. So there are a bunch of stemmers available in Solr. Trey actually is over here, and so at his talk yesterday, he gave a great presentation of the various stemmers and how you as a developer should make sense of them and test them and play around with them. Lemmatization on the other side is not taking a chop off the end approach. It's really mapping forms of words down to their dictionary form based on morphological analysis. So this is how you get, for example, spoke, speak, speaking, down to speak. In particular, spoke. So chopping off the end is an approach that works in general because for the most part in human language, different forms of words just kind of change little bits on the end, but it's not always the case. Okay. So, all right, back to my picture here. So this is, Solr is basically covering everything here, the NLP pipeline all the way down to storage. So the key thing that hopefully you see is that if you want to optimize precision and recall, you should be specifying an NLP pipeline per language, or maybe per family of languages. So sometimes CJK are handled similarly because they have some things in common. already mentioned that the NLP pipeline is mostly specified within your field type, language detection being the outlier there. So we'll talk about a few index and query strategies in Solr. So one of those being you have a separate field per language. Another is you have a separate core or collection per language. And then sort of the bleeding edge new approach that Trey over here, I'll reference him again, and Trey, if you want to wave, Trey developed this new approach where it's basically all languages, one field. So we'll talk about these in a little bit more detail. Look at a performance comparison of the first two. So this is what the field per language approach looks like. So you define a field for each language. So say you're indexing articles or whatever, and you have you have like a content field. So you would define a, say, content CJK field, and you tie your CJK text type to that. You have an English field, and you tie the text English field to that, and define your field types accordingly, differently. Okay, so at query time, one thing that you can do is Boolean query. The other thing that you can do is use dismax or edismax. So here's an example of edismax where you say, okay, my query string is just serie A. Don't even specify fields. This is one of the conveniences that edismax provides. And then you just specify your list of fields to query across. So a very convenient, built into vanilla Solr way of searching searching across multiple languages. So the other approach is a separate core or collection. I'm going to talk about it in terms of core, but it also applies in the collection sense too. Is a core per language. So in this case, you'll define, if you care about 20 languages, you'll have your 20 cores. And in each of those, you'll name your field the same way. So in this case, content. And the only difference is that you'll tie the particular type to it. And because you're generally each core has the blinders on in terms of the language, you could even call the type text. And the only difference is going to be what's in what your analyzer definition is. So querying across the languages is a little different. So in this case, you would specify your field. And then this is just taking advantage of Solr's distributed search functionality where you say, okay, I want this to go across these shards. And then you'll specify your articles English core, articles CJK core, et cetera. And Solr's distributed search takes care of searching across and federating results. So for the approach comparison, so there are a bunch of bullets in each of these that Trey had in his talk, and that in Solr in Action talks about these in more detail. I'm going to simplify it down to just simplicity and speed and compare these two approaches. So in terms of simplicity, generally field per language is the way to go. If you just want to get going quickly, not have the administrative hassle of having to manage multiple indexes. If you want to play with the language detection pattern in Solr and have that feed into one of these approaches, this is the one to use. The core per language, it doesn't really apply because sort of language detection happens too late. It happens before documents get routed. So you could still do some language detection in core per language, but you have to write some code to do that. So why would you do core per language? And generally, it's because if it's a little bit more complicated, it exists because there's a speed benefit to it. And here I'm really talking about query latency. So to put some numbers on that, because people people point that out, but I had never really seen numbers. So I wanted to run an experiment just to at least present numbers behind this. So here's an experiment that I ran where my document corpus was Wikipedia across 9 languages. There are about 9 million articles that I indexed. So in terms of amount of data, maybe it was, 250 to 300 gigs, I think, something like that. So, probably not big data by anyone's definition today, but maybe 10 years ago. But still, I think big enough for an experiment and to get some meaningful results. My queries. So Wikipedia at one point they made search logs available, but then I think there were a bunch of privacy issues and they took them back. So I just did what, I grabbed 1,000 of the most frequently used terms in each language and just randomized, and then used JMeter to just kind of ping for an hour and then look at query latency. So that was the methodology here. Hardware-wise, this was all just a single server, 8-core machine. And here are the results on the bottom here. So as you vary the number of languages on the x-axis, and then you're looking at your average query latency along the y, you can see that if you're just going to query across one language, probably doesn't matter either way. But as soon as you add, if you get up to 4 languages, you can start to see a difference and see performance degrade in the field per language approach. And that difference obviously gets even greater as you're searching across more languages. So definitely keep this in mind. Don't take this as the only answer of which is faster. You should definitely test on your own data and on your own hardware and with your own queries, because there are probably 100 different variables that could give you different results here. One that I'll mention is that we've played around with different approaches of doing this, and field collapsing or results grouping can tend to not make core per language as big of a win for whatever reason. So, I guess field collapsing or results grouping in a distributed sense as a setting is a hard problem. So maybe that's, I'm sure that's why. I didn't really dig any deeper into that, but the point is to experiment on your own with this if you really want to see what the difference is for your case. So the alternative approach is this all languages in a single field. So it requires a custom field type, call it a meta field type, that applies per language concrete field type. So there's no analyzer specified in this field type. It's really just a mapping of language codes to the concrete field type. This was, as far as I know, a patch has been submitted to Solr, or maybe not yet. I know there's a JIRA, but it's sort of on getting there. And like I mentioned, this is something that Trey came up with. So Trey is from Career Builder and has worked with Basis technology, and largely in his spare time is making this happen and trying to get it back into the community. So I guess stay tuned for that. But you can visit his GitHub if you want to go and play around with it. Is it still up there? Yeah. Okay, so this is what it looks like, is basically prepended language codes onto your query or your document. So in this case, I might say, okay, I don't know what language this is in, so I'm just going to prepend English and Spanish because I want to search across English and Spanish, whether it's, search across English and Spanish. So what happens in this new field type is that the prepended codes are inspected. Each concrete field type is then applied, and results are merged and deduplicated and returned back. Why would you do this? And one thing, I would love to get performance numbers on this also. I don't know if Trey, if you've played around with this before, but I'd love to run, the sort of side by side experiment. Just didn't have time to do it. So one thing So this is obviously, simplifies a ton. You have you could have one collection, one field type, and everything just goes into it, and you're supporting multilingual search. The one thing to keep in mind is that results scoring can be a little bit thrown off. So you always talk about precision and recall, but we haven't talked about scoring yet. And the reason for this is that your IDF, which is how frequent the term you're searching for, can be thrown off. And generally, infrequent terms in your corpus are more important, which I think makes sense as a general principle. So that can be thrown off a little bit as if you throw everything across languages into the same field. So the example here that I have is the word soy, which is very common in Spanish, means I am, and then relatively rare in English, the bean or the food. So consider if you have a corpus of Spanish and English recipes, and this is cruel. I'm talking about dessert right before lunch, but this is the thing that I came up with. So consider a query for soy dessert recipe, and you can imagine that across your English recipes, recipe is probably the most common. And then dessert is probably a little bit in the middle, and then soy is probably your least common term. You're going to have a ton of recipes that are, mention dessert and recipe, but soy will be the infrequent term. So, in general, if you just had all of your documents in an English core, and you user issued this query, and you searched across your English core, soy would be used as a very important term in terms of the scoring. And people would get those results filtered to the top. If you mix your English and Spanish in the same field, then soy is perhaps not the most important term in terms of scoring. Maybe dessert would be at that point, and then your soy results get filtered down a little bit, or something like that. So you can imagine that happening. And that may be a problem for you or may not if your application is one where your top few results are really all that matter, then this may be a problem for you. If you only care about recall, you're using Solr to just return all documents. You don't have an application where users are looking, and if it's not in the top 3, you got it wrong, then maybe you can use this and it doesn't even matter. Okay, so I talked about NLP. Okay. I'm not going to spend too much time on this because I want to. This is the marketing stuff where I talk about the NLP products that Basis provides, but we're running a little low on time. So the point here is I mentioned CJK tokenization, stemming versus lemmatization. My company deals in those hard problems and offers products, including Solr plugins, decompounding also. Here's an example of CJK where, Rosette will break a piece of Japanese on tokens properly, whereas if you're using just the standard, one of the options for CJK tokenization is just bigramming. And you can imagine how that impacts precision. So consider searches for single character terms, recall, obviously, and your index size and speed. And this is how you would specify a Chinese text field type with Basis as plugin. And you can go to this link if you want to download the plugin and play with it. Okay, so wrapping up, multilingual search is everywhere. It's one thing that I'm hearing from a lot of people I've talked to here is that it's a problem for them. People have products that are English only or maybe a handful of languages, and they want to go international. So multilingual search, we experience it everywhere, and for the people in this room, is probably a problem that you're dealing with now or may be dealing with. We talked about, obviously, Solr as the platform and the different options. And then one thing that I wanted to really get have you guys get out of this is that your search quality really hinges on that NLP pipeline at the top. If you don't have if your NLP pipeline spits out garbage, that's garbage into Solr, and you're going to get garbage out. So that's one thing that I want to get across here, and that's all I have. It's 12:45.